Okay, today we're going to talk about using a dual H-bridge driver, the inexpensive circuits that you can find online anywhere from 26 cents up to 88 cents depending on the quantity you buy. Usually I get mine on AliExpress, but in this particular package configuration, and might be easier to see it on this printout like this, like that. In this case I'm using the MX1508, but the MX1616 works, and they also sell the same package configuration as an L298n mini. And what we're using here for this simple demonstration of turning it into an oscillator, which we're using to alternately flash LEDs, I'm only using half of it. You can build two oscillators on here, and again in the next video I'll show how to do that, where I wanted to make a tone, where I made my top half of the chip a tone frequency generator for driving a speaker, and I had the bottom half of the chip used as the gate to turn the tone on and off so I could get a beeping sound to put into my 3D printed Vanishing Shadow robot project. So in order to do this, and again this is just roughly showing what I have set up here, you've got your top two pins on this. You're going to have your V plus going in, you have your ground. You're going to take your input 1, tie it to your V plus. Then you take your input 2 and you're going to feed it back around through your timing resistor. In this case I have a potentiometer set up, and I'll show you how that works in a second. You're going to bring that around to the output number 1. Then you're going to need a capacitor, depending on whether you want to be in the audio frequency or whether you want to be in the flashing frequency. That's going to kind of determine what this is. If you're trying to generate a audible tone, you'll probably want to use something like a 0.1 UF capacitor. And the resistance of this is going to vary. It depends on a few things: how many volts you're running the circuit on and what range you need. But generally you can be anywhere, in between 100 ohms on the low end to maybe 330 ohms on the high end. So in this case I wanted to show that the pin 1 is both going high and low, so that's why I put the two LEDs in there, tied one to the V plus through a current limiting resistor, tied the other one to ground through a current limiting resistor. If I'd been wanting to make just a tone oscillator, I would have brought it out and I'd use a current limiting resistor to the speaker, and you can actually tie the other side of the speaker either V plus or ground. It doesn't make any difference since you have an alternating current here. But the current limiting is important because the output of this can sync up to 1.5 amps. And for example, if you were running this on 10 volts and you could sync 1.5 amps, and you connected a very small 8 ohm half-watt speaker like you might find in a toy or something on there, it isn't going to take long to burn that speaker up, because this has a potential of producing 15 watts of output under those situations. Now on 3 volts, or let's go clear down to 2 volts, the bottom end of this chip, the chip will run between 2 and 10 volts. So let's say you only had 2 volts going in. That's still 3 watts of power there. So anyway, when we talk about in the next video making a beep beep tone generator for my robot project, I ended up using I think I have about 20 ohms to cut it back, and it was still plenty loud, and it didn't have to worry about the speaker getting fried. But this is basically using 1/2 of the dual H-bridge chip as an inverter. So anything that happens on this input 2, the opposite is going to happen on this output 1. So that's why we bring it back around to run through the RC, resistor and capacitance, and keep things oscillating. And as you can see here, in this particular case I've got a potentiometer on here, and as I make the resistance lower, you can see it speed things up greatly. They look like they're both on, but they're actually flashing too fast to be seen. Now I'll start slowing them down. So one interesting thing to notice when I get it going real nice and slow here, it tends to lose its symmetry as we get lower and lower. This one that's tied to the ground, which means the positive half of the cycle, anytime you see this red lit, that's when the output has gone positive, becomes longer, and the negative half of the cycle becomes shorter. It no longer appears to be a square wave as this resistance value increases. Something to keep in mind. Something that I used to my advantage when I did my beeping tone project, because I wanted the beep very brief and only about once a second. So the whole other half of this chip right now is vacant. It's not being used. We could do anything we wanted with it. Of course, you don't have to flash LEDs. Let's say you had a robot project in mind where you might want to replace these LEDs with motors. You could have two different motors. You could change your timing, you know, put in a larger cap here for a longer timing cycle, and you could have, say, maybe this is your walk motor, and you'd want it to walk for X amount of time, and then you want it to stop walking and then have some other function happen. You could have it tied off to the other end. So just depending on how you tether it all off, you can do a lot of things. If you wanted to do motor reversing, then we could use the whole bottom side of this H-bridge driver being controlled by this, and we could reverse the direction of a motor. We could go forward and backward. What else? I think that is about it for this video. I'll put a link to the first video I did on this showing how to do motor reversing, single line control, reversing a DC motor, and how that all works, and I kind of walked you through the logic. You know, this is showing if you put highs in both inputs at the same time, both outputs will be low. This is the invert state. When they designed this chip, they designed that to be the braking state for going into a brake mode. And by the same token, they had it if you made both inputs low, the output are going to go into an open state, no conductivity at all. It's an open circuit. The other ones kind of follow. If you have a low here, you'll have a low there. If you have a high here, you'll have a high there. So in these two modes, you would just consider it a driver buffer, taking a very low input signal like you might have from any circuit or sensor to being able to drive 1.5 to 2 amps on the output. Okay, so there you have it. You can build a simple flasher and still have half the chip available for doing other things using a dual H-bridge chip.